Today, we're going to try to find out if this is true. So, we've got everybody's body temperatures up here. I want you to find, using your calculator, the sample mean, x bar, and the sample standard deviation, Sx. And our n is 18, by the way. N is 18. Does anybody have a sample mean for me? 97 point, I'm going to take it out to 3 decimal places just so we can see any kind of variation here. 483, let's take it out there. If we round it to just 1 decimal place, 97.5, but I want to kind of see what's going on. Sample standard deviation, Sx. 0.373. All right. So I want to walk through a significance test on this. We are going to assume that the conditions have been met. So we don't have to check conditions on this one. Normally we have to go through and check our conditions, but we're given this one today. What would the parameter be here? First of all, which parameter are we going after, mu or p? Mu. So the parameter mu equals the true body temperature, or sorry, true mean body temperature, my bad, because mu is the mean. True mean body temperature yes, for all high school students. If we're doing significance testing, we need hypotheses. Null hypothesis is that mu is equal to 98.6 degrees. That's coming from up here. And what would our alternative hypothesis be then? Not equal to 98.6 degrees Fahrenheit. This is what I'm looking at. We're looking to see if it is different from, not if it's greater than, not if it's less than, but just different from, which would be a not equal. What statistics do we have? We have X bar, that is 97.483 degrees. Sorry, I need to label that. And then we have SX, which is 0.373. Sample standard deviation. Alpha level, did they give us an alpha level? So what do we typically use if they don't tell us? Yes, 5%, 0.05. When we do confidence intervals, that would be 95%. When we're doing significance testing, we do 5%. All right. Let me grab these pieces so that we have those on the next screen. Sorry. There we go. What would the name of our procedure be here? Yes. One sample. T-test. Why not T-interval? We're doing a significance test. When we're creating a confidence interval, that would be a T-interval. This is a T-test. 4, and then we name our parameter here. The whole reason that we're doing this test is for mu. All right, so what is my general formula when I'm doing a significance test? This is true whether it's for parameters or means. Yes, sir. Oh, sorry. Go ahead. Tell me. Yes. Standardized test statistic is equal to the statistic minus the parameter over the standard deviation. We have had to approximate the standard deviation because we don't have the population standard deviation. What is the specific formula that we will be using? Yes, T equals x bar minus mu over Sx divided by the square root of n. Go ahead and calculate our t-score. You guys remember what our n was? 18. What do you guys get? So here's our test statistic. We We need a picture to go along with this. Am I going to draw a normal curve? No. What are we drawing this time? A t-curve, t-distribution. Looks a lot like a normal curve. What has to go in the middle? 0 has to go in the middle when we do this. We have to label it. Do I label it like this? T and then degrees of freedom. How many degrees of freedom do we have? 17. So you have to have T and whatever the degrees of freedom are inside the parentheses. We don't have to have as much information. And then we're going to put our test statistic on here. Negative 12.705. Way over here. We also have to do positive 12.705. Why? Yes. Two tails. We're two-sided because it was a not equal to. It wasn't a greater than or a less than. It was just a not equal to. All right, so our p-value, to find the p-value, we need to do T CDF. What would come after that? Lower bound, so negative something huge. I'm going to do negative 10,000. Then our upper bound. Negative 12.705. Here's my upper bound. And then we need what? Degrees of freedom, which was 17 times 2, because it is two-sided. If I just do the one, I'll only get this. I want both sides of that. What'd you get? Scientific notation. So on my calculator, when I did the p-value and then I times it by 2, my calculator looks like this. Is that similar to what you guys see? All right, so writing that out, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 4, 1, 8, 1, 2. That is really tiny. So what does that p-value mean? When I'm writing my conclusion here, what does it mean to have a p-value like that? We're going to reject the null hypothesis. That's my conclusion. What does this p-value tell me, though? Yes?
It's that percent probability likely to occur purely by accident. So there would be very likely to get the value of 98.6 degrees is like a standard temperature.
Yes. So what we're seeing here, assuming that our mu, our null hypothesis is true, assuming HO is true, and we assumed that mu is equal to 98.6 degrees Fahrenheit, there is this super tiny probability that we're going to see what we got in our sample purely by chance. I'm going to write it out in scientific notation because it's times 10 to the 10th. Sorry, 10 to the negative 10th, my bad. Probability of getting an X bar of 97.483 or lower or I have to think about the other side of that. Because 97.483 is smaller than 98.6, right? How much smaller? So to get the other side of that, I would take 98.6 degrees and I would add this. So 99.717. So we have this super tiny probability of getting an X bar of what we saw in our sample, or smaller, or the other side of that, 99.717 degrees or larger, purely by chance. That much right there is an interpretation of my p-value. Which we need to do. We need to interpret the p-value. We need to explain what this thing means. And then we go on to make our decision and our conclusion. So our decision is to reject or fail to reject the null. Because 4.1812 times 10 to the negative 10 is less than 0.05. We reject the null. Do we have convincing evidence for our alternative hypothesis? What was our alternative hypothesis? Yes, we have convincing evidence that the true mean body temperature of high school students is different from 98.6 degrees Fahrenheit. Here's our decision and our conclusion. When I say conclusion, it's our conclusion about our alternative. That is a ton of stuff on that screen there. Super tiny writing. Sorry, guys. Does anybody need me to leave this up a little bit longer? So I want to look down at the bottom of the page. A different class did this exact same activity, and their results are listed below. What did they find their sample mean to be? 97.9. And their sample standard deviation? 1.6. How many students did they have? 30. Oh. Let me recopy this just so you can get it again if you need to. There we go. I want to use t-test on your calculator to find the p-value. So t-test on the calculator. I'm going to go to stat. I'm going to go over to tests. We're going to do option 1 where it says, or sorry, option 2 where it says t-test. Do I have raw data from this other class? No. So I'm going to enter statistics. I'm going to arrow over and hit enter. So that now that's the highlighted piece. X bar, I'm sorry, null mu. Yep, 98.6, right? X bar, 97.9. Sample standard deviation, 1.6, and an N of 30. We want this to be the not equal. And then we're going to come down to calculate. What is the p-value? 0.0232. Can you use the calculator to do the work part of your test? Yes. If it's multiple choice on the AP exam, go for it. If it is in the free response section, you have to show the work. Just doing it on the calculator and writing down those numbers will get you no points for that section. So you have to show the work. You're welcome to use your calculator to double check if you want, but you have to show the work in that section. That's why we haven't talked about this until now. All right, so we have our p-value, 0.232. Would we reject the null at an alpha level of 0.10? Yes. Because 0.0232 is less than 0.10. Would we reject at an alpha level of 0.05? Yes. (0.0232) is less than 0.05. Would we reject at an alpha level of 0.01? No. 0.0232 is greater than 0.01. I want to use the calculator function that will calculate an interval for us. We can use the calculator to give us a confidence interval. We haven't done this before because, again, on the free response section, they need to see all your work for it. but we're going to use t interval. So I'm going to go back to my calculator here. I'm going to go to stat. I'm going to go over to tests again. I haven't really used this option much. T interval, you might have to scroll down on yours. It should be option number 8 for t interval. We're going to enter our statistics. Hopefully it grabbed your old statistics and filled those in. We wanted to calculate this at a what percent first? Yep, 90%. So our C level is 0.9. I'm going to come down to calculate and hit enter. There's my interval. 97.404 to 98.396. Would we reject the null if that is our interval? Yes. Yes, why? Does not contain 98.6. Interval does not contain 98.6. I want you guys to do that for 95% and for 99% now. What did you guys find for the 95% confidence interval? $97.303 to 98.497. With that interval, would you choose to reject the null? Yes. Same reason, right? The interval does not contain 98.6. What about the 99% confidence interval? 7.095. 98.705. Would you reject or fail to reject? Fail to reject. The interval contains 98.6. So I want you guys to look at these. Talk to me about the relationship between a 90% confidence interval and a 10% alpha level. They both rejected the null. If I add 0.90 and 0.10 together, I get 100%. So a 90% confidence interval, I'd come up with the exact same result to reject or fail to reject. As I would with a significance level, it has to be two-tailed with a significance level of 10%. What about 95% and an alpha level of 0.05? Both of these we reject. 95% or 0.95 added to that alpha level, that adds up to 100%. 99% and an alpha level of 0.01. In both of these, we failed to reject. So we're reaching the same conclusions whether we're using a confidence interval or a two-tailed significance test. So I'm going to kind of record that idea down here. The decision of whether or not to reject the null is the same using a confidence interval or a two-sided significance test. Exactly the same outcome, confidence interval or a two-sided significance test. So when we use that not equal to, flip it over, talk about our big ideas. Four-step process is the same. If you guys want to copy it down again, I think we've written it down 5 or 6 times now. Four-step process isn't going anywhere, does not change. When we do a significance test, we need 4 pieces in our state, though. Confidence interval, we only need 2, 3. You don't have to put your statistic there. But when we're doing significance testing, you have to define your parameter. It is not enough to just say parameter equals. You have to say what your parameter is. Is it a proportion P, or is it a mean mu? Is it a difference of proportions, P1 minus P2? Is it a difference of means, mu1 minus mu2? You have to state your hypotheses, state your statistic, and your alpha level. In the plan step, give me the name of the procedure you're using. We've talked about Z intervals, Z tests, T intervals, and T tests. And then we have to check our conditions. We got out of that today, though. In the do stage, give the general formula, give the specific formula, show your work, test statistic, p-value. I forgot one other piece here. Picture. In your conclude step, you interpret your p-value. Give your decision, either reject the null or fail to reject the null, and why. And then what was your conclusion about the alternative hypothesis in context? We have convincing evidence for, and then name what your alternative hypothesis was. Or we do not have convincing evidence for the alternative hypothesis. confidence intervals and two-sided tests. If the null value is in the interval, the null is a plausible value, so we would fail to reject. If the null value is not in the interval, then we're saying that the null value would not be a plausible value for the mean, and we would reject the null. A C% confidence interval will make the same decision as a two-sided significance test with alpha being equal to 1 minus whatever that C% level is. Once you get these things written down, go ahead and try the check your understanding. 2 questions, neither of them should be ridiculously long. The first one, state your hypotheses and define your parameter. And in the second one, they give you a confidence interval. And I want you to tell me whether you would reject or fail to reject the null and why. What would the hypotheses be here? Yes, something along those lines, yes. What would the null hypothesis be? Mu is equal to 32. What would the alternative hypothesis be? Mu is not equal to 32. What is mu here? Yes. True mean flight time of all 18-inch helium balloons from this company. "95% confidence interval is what they gave us. So I can evaluate this for a not equal, a two-sided alternative hypothesis at the alpha equals 0.05 level. Would you reject or fail to reject?
That's a clear reject. Or we can reject.
So in part 2, here's my interval, 28.5 to 31.4.
How we reject them?
Reject. Why?
Because it's not there.
Not in the interval. Because the null value of 32 is not contained in the 95% confidence interval, we would reject the null at the alpha equals 0.05 level. We'd find a p-value, if we did a significance test here, of less than 0.05. Have a fantastic rest of your day, guys. Tomorrow, I will tell you what Thursday looks like for us. I won't see you in here, but there will be a very, very short thing that you need to do in Canvas so that everybody gets counted as being present on Thursday. Super short, probably just like 2 quick questions. Should not require any deep statistical thinking.